So, good afternoon, everyone. I am going to present to you this academic study which was undertaken on a Ukrainian bulls painting made of a vinylic dispersion paint on a hardboard panel. As you can notice here, the paint had a grainy surface with dirt embedded in the varnish. The conservation treatment considered was an aqueous cleaning. However, vinylic dispersion paint are known to be water sensitive. In order to reduce the swelling and the loss of material, the use of water buffered to a suitable pH and conductivity is advised. Nonetheless, the traditional aqueous solutions are still used in daily conservation practice. Our scientific study focused on assessing the impact of aqueous cleaning on the vinyl dispersion paint, comparing the surface before and after cleaning with both aqueous solutions and two gels. Macrotopography was found to be a suitable technique for our investigation, which was carried out on mock-ups. The painting material were identified thanks to different analytical techniques as well as documentation. The stratigraphy shown here highlights the components of the paint. A hardboard panel, which is called Bavatex, pigments ground in a vinyl dispersion, a first layer of varnish in paintings applied later, and a last varnish layer. Ukrainian Build used a binder sold under the name dispersion binder. And here you can see an extract of the technical data sheet which details the component identified. A vinyl homopolymer dispersion, two external plasticizers, a polyvinyl alcohol colloidal protector, as well as other surfactants. Pigments identified were mainly mineral, including lithopan white and Prussian blue. The first step of the study began with cleaning tests performed on the paint. The pH and the conductivity were measured with an agarose gel, and data recorded were around pH 6 and 200 microsiemens. Among the different aqueous cleaning systems tested, the ethylene diamine tetraacetic acid, or for short EDTA, was the more efficient solution. Mock-ups were made with materials from the artist studio and therefore very similar to the paint. Only two pigments were used as a monochrome layers, lithopan white and Prussian blue. Mock-ups were subjected to accelerated light aging, and this is also interesting here to see the difference between before and after light aging and consequent yellowing. Two aqueous solutions and two kinds of aqueous gel were made up. EDTA was employed as the main component of the set. The pH and the conductivity of the water were adjusted according to the measurements of the specimen surface, therefore pH 5 and 2000 microsiemens. The 1% triammonium citrate in water was used as a traditional cleaning solution with no particular focus on pH and conductivity. EDTA buffered solution was the efficient one selected during the preliminary cleaning test on the paint. Then the Velvesil Plus Gel and the microemulsion were selected for their ability to remove materials from water-sensitive surfaces. A small quantity of EDTA aqueous solution was added in those two add-on set solution, mixture. All the solution or mixture were applied on the mock-ups with cotton swabs and rinsed with an appropriate solution. Microtopography is a topographic tool which operates with the confocal technology based on a chromatic coding and white light. This is a light beam directed on the mock-ups which scans across the surface. It allows the measurement of small variation of elevation and surface roughness through chosen roughness indices. In order to understand the resultant modification scales on the mockup, we compared the arithmetic surface variation, the maximum depth of void, and the maximum area of bumps. We obtained three-dimensional images, which gave an indication on swelling, and two-dimensional images allowed visual assessment of surface modifications. To assess the impact of aqueous cleaning on the vinyl dispersion paint, topographic data were recorded before cleaning and compared with the readings on the same areas. Here, I will show you only the two- and three-dimensional images, but I think they speak by themselves. So, first of all, the results on the white mockups. Microtopography indicate that the white mockups cleaned with the Velvesil Plus on the top exhibited surface swelling, as you can see here on the three-dimensional pictures. The two-dimensional pictures images showed deep scratches and abrasion after cleaning. The measurement on the white mockups cleaned with the microemulsion indicate pronounced surface abrasion. Two- and three-dimensional images confirm the measurement, showing significant modifications and sometimes leading to a complete surface change, as seen here on two-dimensional images. The result of white mockups cleaned with the EDTA solution are pretty inconsistent. However, a general trend emerges from the topographic images. As shown here on 3D pictures, mockups seem to have a propensity to swell, while two-dimensional images indicate slight surface changes. The surface texture is slightly reduced and resulting in a smoother surface compared to the previous specimens. Measurement on specimen cleaned with the TAC solution indicate a swelling trend confirmed by 3D images. Two-dimensional images indicate significant surface modifications with several scratches, while topographic forms disappear. Results from all the blue mockups indicate a significant abrasion, varnish thinning, pigment extraction. But specimen cleaned with TAC indicate less significant pigment extraction. It was thought that it may be due to the weaker chelating action of the citrate for iron. Corresponding cross-sections were obtained, which confirmed that the varnish was thinner after cleaning. Though it was thought that the affinity of EDTA for iron-containing pigments, such as Prussian blue, could cause major surface abrasion. To sum up, white mockup cleaned with the EDTA seem to have a high propensity to swell, but surface modifications are minimized compared to the other cleaning tests. The abrasion is less pronounced than that following cleaning with Velvesil Plus and microemulsion, despite the higher water content of the EDTA solution. Results from specimen cleaned with the TAC solution indicate greater topographic changes. This suggests that non-adjusted solution may favor the softening and consequent abrasion of the paint. Well, in conclusion, it was assumed that gel application and consequent rinses could have led to physical damage and surface abrasion. Results suggest that the method of delivering the cleaning solution influences surface modification more than the type of solution itself. So, white samples cleaned with EDTA in adjusted water exhibited less damage. In our case, the adjusted solution appeared to give the best results. Eventually, according to the results, the chelating agent was changed for the cleaning of the paint. Thank you for your attention.